finally, our last lesson of this section on lines. We're going to look at parallel and perpendicular lines, and we'll start off with parallel lines. So our old definition of parallel lines probably looks something like this. Lines that never cross. And that seems a pretty good definition, but why do the lines never cross? That might be the question. So our new definition of parallel lines has to wait a minute or so. And here's what I want you to do. I want you to go ahead and plot these points, and they represent points on two different lines. And I would like you to answer, are they parallel or not? And if they are parallel, how do you know? And don't say they look parallel. That's kind of okay, but I could probably draw you a picture where the lines look parallel and they actually aren't. So again, draw the picture, see what you see, and see what you say. Okay, so here's what I'm going to do. And I'm going to plot these pair in blue. And again, I can't use a ruler, so this is going to be my best my best picture. You have to take it with a grain of salt that you are using a ruler, so your picture is going to look a lot better. So this one right here, I'm going to try to connect the dots as best I can. That's a little bit off, but I'm going to leave it. So there's that line, and it has a positive slope and a negative y-intercept, and away we go. Well, I'm going to plot this one in green. So here's negative 8 comma 0. And here's 0, 9, and I'm going to try to draw a line there. So have a look at your two lines, have a look at my two lines. And again, I'll call it a blue line and a green line. And do they look parallel? And I think if you said, do they look parallel, the answer would be yes. But how do you know they are parallel? What did you try? Well, one of the things we've talked a ton about in lines is slope. And I'm going to give you your new slope, your new definition for parallel lines right now. And it's going to have slope in it. Parallel lines are lines with the same slope. And if you have two lines with the same slope, they will never ever cross. So the slope of the green is equal to up 9, right 8. So the slope of the green is, again, 9 over 8. The slope of the blue, guess what? It is 9 over 8. So given that the slopes are the same, these lines will never cross. And think about that for a sec. Does that make sense? If they're going up by the same amount all the time and they're never getting closer together because they physically can't get closer together, either way, whether you go to the right or whether you go to the left, the parallel lines will never, ever cross. Now, another way that we could determine that these two lines were parallel, and I don't want to do this, but another way is, we could figure out that distance there, and we could figure out a distance here, and if those distances were equal, that's another way of showing that two lines are parallel. Think of railroad tracks. Like, if railroad tracks have the highlight is supposed to represent, some metal or wood or whatever. If those distances are the same, the tracks will be parallel, and that's really important for a train. If the tracks aren't parallel, the train falls off the track. So here's the key idea then. When you hear or see the word parallel, parallel is a slope word. So if parallel is a slope word, then those natural questions are, draw a line that's parallel to this line, or find a point on another line that's parallel to this line, or as this question says, are the two lines parallel, yes or no? So in our first example on the left, both of those are in general form, and I gave you a shortcut for slopes of lines in general form. So for the one on the left, the slope of this one on the left would be negative 3 over 1. The a is 3 and the b is 1. For the slope on the right, we would have negative, the a is 3 and the b is negative 1. So therefore the slope of this line is positive 3 over 1. And given that the slopes are not the same, one is negative 3, the other is positive 3, they're not equal. Now the other way you could do this, of course, is put each in mx plus b form. And if you want practice, go ahead and do that, and you will see that the slopes are exactly the same. Now, the second question is entirely easier because both of those are in point slope form, and hopefully we know that the number in front of the brackets represents the slope. So as the slope here and the slope here are both 4, these lines are parallel. And of course, these are not parallel. So parallel is a slope word. If you know something about the slope, then you know something about if the lines are parallel or not. So again, in doing your homework, we're going to do some practice problems. But the key idea is whenever you see the word parallel, you must think slope. So then the next kind of slope we're going to look at is perpendicular slopes. So first of all, what does perpendicular mean? Well, perpendicular means two lines that cross or meet, they don't have to cross, at 90 degrees. So at a right angle. So if two lines are meeting at a right angle, they cannot possibly have the same slopes. So have a look at these two lines on the diagram here. And again, if you look at these two lines, one of them has a positive slope and one of them has a negative slope. And what I'm going to say is that these are perpendicular. Now, even if it doesn't look like it, I'm going to tell you that these lines do cross at 90 degrees. And what I want you to see is, I want you to see what the slopes look like. Now, they're, like I say, one is positive, one is negative. They're obviously not going to be the same, but let's see what they look like. So I'm going to call this one line A, so we know what we're talking about, and line B. And in order to find the slope of a line, all you need is two nice points. So I'm going to pick that point there and that point right there. So of line A, my 2 points are negative 2 comma 0 and 0, negative 3. And the slope would be down 3, so down 3 and right 2. So the slope of A is going to equal negative 3 over 2. What's the slope of B? Well, again, we'll pick two nice points, that one and that one. So we have negative 6 comma 0 and we have 0 comma 4. And in order to figure out the slope of this one, what we'll do is we'll go up that many, which would be 4, and we go across that many, which would be 6. So the slope of line B is going to be 4 over 6 or 2 over 3. Now look at these two numbers. Again, they're not equal, but there is something kind of funny happening. They look kind of the same. So again, make this note, they're kind of the same numbers, kind of, bad English. But they're upside down. So in one, the 3's on top, and the other, the 3's on the bottom, and on the other, the 2's on the bottom, and the other one, the 2's on the top. And the other thing that is a little bit different, so there's the stuff that's the same, is one is positive and the other is negative. And this is going to be the relationship you see with every perpendicular slope. The slope of 1 is going to be called the negative reciprocal, and I'll write that down in a sec. So perpendicular is a slope word. As soon as you see the word perpendicular, then in order to show something is perpendicular or not, you're going to have to find the slopes, and the slopes are related. The slopes of perpendicular lines are negative reciprocals. They're not equal to each other, but there is a funny relationship. They're negative reciprocals. Now that's a really horrible word. So here's all I think of. We flip the numbers and change the signs. So again, if I know the slope is negative 3 over 2, well, I know the other slope is positive, because opposite of negative, and instead of 3 over 2, 2 over 3. And this relationship is always true, just like relationships of parallel lines are always equal. Now, in these ones right here, I'm just gonna do one. I'm just gonna do one example. It really doesn't matter of the other one. If you want to do this one as well, go ahead and do it. But I'm just gonna use it for a space. I really should have had a grid in my notes. So over here, I'm just going to sketch this picture of the one on the left. And I'm going to try to be as accurate as I can. I'm going to try to scale this nicely, but it really doesn't matter because hopefully the question is obvious. So in this one right here, what we're asking is, are the lines that go through these pair of points perpendicular? So I'm going to go ahead and I'm going to do this one in blue and this one in green. So the green one is 3, 0 and negative 3, 4. So there's our green line, and I'm just gonna again sketch it. A ruler is way better. And here's my blue line, 1, negative 4 and negative 1, 1. And again, I'll eyeball that. So by looking at my picture, if I drew anywhere of a decent picture, they are not perpendicular. That is not a 90-degree line. But let's go ahead and find the slope of the blue line. So the slope of the blue line, I'm not gonna pollute the picture. The slope of the blue line, if you counted, is negative 5 over 2, and the slope of the green line is negative 4 over 6. They're both negative, so they absolutely cannot be perpendicular. But also, even if we simplify this to negative 2 over 3, if you flip the 2 over 5, you flip the 5 over 2 to 2 over 5, it doesn't equal to 2 over 3. So this was our last small little lesson of the unit around, again, other things that slope helps you with. Slope helps you show something is parallel. Slope helps you show something is perpendicular. And those are special relationships. Those are special kind of angles. So they turn up in all sorts of places.